Welcome to this explainer. Today, we're building an absolute rock-solid coding foundation. Look, C++ is the ultimate backbone of both tech interviews and modern software engineering. So if you've been frantically searching for a C++ for loop tutorial, or maybe you really want to master control flow statements in C++, or honestly you just need a straightforward guide to loops in C++ for beginners, you are exactly in the right place. We're going to cover all of that today. We'll dive deep into the essential for loop in C++ and totally demystify how this language actually processes our data. Let's get right into it.
Here's our mental roadmap for today. We're starting with the power of C++, moving through variables and gang territories, checking out the grocery store operators, dodging operator precedence traps, making decisions with control flow, and finally, testing your logic.
Section 1. The power of C++. Building the foundation of modern apps.
Simply put, you really just can't skip C++. It is the absolute core of those real-world unicorn apps you use every single day. Think of your favorite food delivery platforms. These massive systems rely heavily on object-oriented programming to manage things like users, restaurants, and drivers as data objects. Now, if you're a beginner and feeling kind of intimidated by programming, take a breath. Don't worry, we're going to break everything down completely using highly relatable, real-world analogies. You've totally got this.
Section 2. Variables and gang territories. Understanding data scope and constraints.
So a standard variable is basically like an open backpack. You can put a laptop in, take it out later, swap it for a book, whatever. But a constant, which you define with the keyword const, is entirely different. Constants are like sealed boxes. Once you put a fixed value inside, say the mathematical value of pi or the speed of light, and initialize it immediately, that box is taped shut for good. You absolutely cannot swap it out later in the program.
Now, when we do use regular variables, we really have to talk about their scope. I like to call this the gang territories analogy. A local variable is strictly confined to its specific block of code. It only has power in its own little neighborhood. A global variable, on the other hand, is declared outside of all functions. It's nationwide. Everyone in the program knows exactly who it is. But here's the catch. If a local variable and a global variable share the exact same name, the local variable always gets priority in its own territory. This is especially crucial when we talk about loops. If you create a variable specifically inside a loop's syntax, it literally dies the second that loop finishes. If your program needs you to use its final value later, you must declare it out here in the global, or at least a wider local territory, first.
And this brings us to a massive interview gotcha. If you declare a global variable but forget to assign it a number, the system safely defaults it to 0. No harm, no foul. But if you forget to initialize a local variable, total chaos. The compiler just assigns it a random, unpredictable garbage value based on whatever leftover data was sitting in that exact memory slot. So pro tip, always initialize your local variables.
Section 3. The grocery store operators. Calculating and evaluating data. Think of code operators just like a grocery store checkout. The assignment operator, that single equals sign, is basically setting the price on the shelf. Arithmetic operators, your plus and minus, are adding items to your total bill. Relational operators, like the double equals or the greater than sign, check if you actually have enough money in your wallet to pay. And then there are the increment operators, the plus plus, which automatically scan your items one by one at the register. Let's look a little closer at those increment operators, because honestly, they trip up everyone. Pre-increment, where the plus plus is before the variable, means do the math right now and then use the new value in the expression. But post-increment, where the pluses are at the end, is a little lazy. It essentially says, I'll give you the current value to use in your equation right now, and I'll quietly add one to myself in the background for later. You really want to keep that laziness in mind, because it's definitely going to come back to haunt us.
Here's another super common trap. Division. If you divide the integer 10 by the integer 3 in C++, the answer isn't 3.33, it's just 3. The system completely truncates the decimal. To get the precise answer, you have to explicitly introduce a floating point number, like 10.0. That triggers an implicit type conversion, upgrading the result so it actually includes the decimal.
Section 4. Operator precedence traps. Solving complex expressions correctly.
Now, consider the hierarchy. We're not in standard math class anymore. Postfix operators, that lazy increment we just talked about, actually beat out prefix operators, and both of them beat standard multiplication and division, which in turn beat basic addition and subtraction. It's a whole new order of operations.
But what happens if two operators share the exact same precedence level?
like a plus and a minus. That's where our tie-breaking rules called associativity kick in. The standard flow is left to right, just like reading a book. However, prefix operators and assignment operators read right to left. Oh, and of course, parentheses will always override the standard precedence. If it's in brackets, it goes first, every single time.
Before we leave operators, here's a really surprising fact about bitwise operators that interviewers absolutely love. A bitwise left shift physically shifts the binary bits of a number to the left under the hood. And the mathematical result of this? It instantly multiplies the value by 2. A right shift divides it by 2. It's an incredibly fast, low-level math hack that is great to keep in your back pocket. Section 5. Control flow and decisions. Building pathways in the code.
By default, code executes sequentially, line by line. But real-world software requires dynamic jumps. Enter the for loop, an entry-controlled loop built on 3 crucial parts, even though technically they're all optional. First, initialization, like setting an integer I to 1. This happens strictly only once. The program never goes back here. Second, the condition, like I is less than or equal to 4. Because it checks this before entering the loop's body, if it's false, the loop instantly terminates. But if it's true, the code inside runs and prints out the number 1. Finally, updation. After the code runs, control jumps straight here to update the variable in memory, maybe using an increment to bump I to 2. Then it loops right back to the condition. This exact cycle repeats step by step, printing 2, 3, and 4, until that condition finally evaluates to false and the loop terminates completely.
And outside of loops, we use if-else blocks to make these jumps. Think of the classic grading analogy. If I score 80%, I get a new bicycle. The computer evaluates this top to bottom. If that first condition is true, it executes the code and instantly exits the block. It won't even bother looking at the rest. But if it's false, it cascades down to check the else if. And if all else fails, it hits the else block, which is just the default fallback. It ensures exactly one pathway is taken.
Section 6. Test your logic. Can you predict the output?
All right, here's your logic challenge for the day to wrap this explainer up. First, if a is initialized to 4, what is the exact output of the expression a plus a plus plus times 2? You're going to need to apply those precedence rules and remember exactly how that lazy post increment works. And for a bonus loop challenge, if we took our earlier loop that counted up to 4, but changed the updation from an increment to a decrement, essentially changing I++ to I-, exactly how many times would that loop run? Think carefully about what happens to the condition. Drop both of your calculated answers down in the comments. Thanks for joining me on this explainer, and keep coding.